Hello, my math friends. This is Mrs. Schlecht, and in this video, we're going to start looking at algebraic expressions. All right, so before we get into all the fun, there's a few materials that you're going to need in order to be successful for this activity. First, you're going to need your Envision textbook with our robot friend on the front. Second, you're going to need your math notebook to take those great notes. They're going to be awesome. Third, you're going to need that pencil to take those great notes. And fourth, last but never ever least, you're going to need that positive math attitude. Okay, friends, big stuff. Oh my gosh, we're gonna start algebra. Oh my gosh, I can't wait. Can't wait. So super excited. If you're a little nervous, take a breath. You're going to be great. You're going to be great because you're smart and you're brilliant and you're beautiful and you can do wonderful things. And this is going to be so cool for you. Okay. So this video goes with lesson 3-4, which is in your Envision book. And the key concepts page for this lesson is on page 148. Okay, my friends. If you can't tell, I'm like super duper excited because this is like the beginning, my friends, the beginning of like this long journey you'll have with algebra. This is the start, and I'm so thankful I get to be here for the start of your journey. It's going to be awesome. Before we get started, there's some words that we just need to talk about so that we're all on the same page, okay? Here are those words. So first, an algebraic expression, and then we have a variable, a term, and a coefficient. Let's look at each of these words. All right, my friends, so we're going to use this expression right here to help us understand these words right over here, okay? So first, algebraic expression. Dude, this whole thing's an algebraic expression, okay? The whole entire shebang, this whole thing counts as an algebraic expression. What makes it an algebraic expression, Mrs. Schlecht? That is a fabulous question. Thank you for asking. What makes this an algebraic expression is the second vocabulary word, variable, that we're going to talk about. All right, so a variable, my friends, is this letter R right here. And what a variable means is it's an unknown. It's something that we're trying to figure out. So an algebraic expression is just a math expression that has at least one variable in it, right? One letter. There's going to be letters in math now. You can do it, right? But an algebraic expression is one that has at least one variable in it. And again, that variable is that unknown. It's our mystery number. You may have seen a variable look something like this before. So, my friends, back in the day when you were like little kids, like in elementary school, you know, before you're all like wise and knowledgeable like you are now, you may have done something like this, where you had like 5 plus blank equals 9. Well, in that case, we might not have ever called the question mark a variable, but it was, right? It was standing in for an unknown number. Now, this is pretty easy to solve, right? We know that that question mark is actually the number 4, right? But it's the same idea. So you've done stuff like this before where you had some information and then there was like some unknown business that you had to figure out. Same sort of thing here with these algebraic expressions and these variables, my friends. You have enough information to solve it, but the unknown, right, is represented by a letter, which we call a variable. All right, just a quick little note about variable. Okay, variable, my friend. You know how multiplication, we typically use an X to represent multiplication? So cool. However, now we might be using an X as a variable, right? That like stands for an unknown number, and it doesn't mean multiplication. So when we're doing these algebraic expressions, there's actually kind of like a new way to show that you mean multiplying so that your X is like a variable and it's not like multiplication and we're like all on the same page. Let me show you what I mean. Okay, before we've done multiplication like this, right? 5 times 2 equals 10. We know that, right? However, that X, right, with our algebraic expressions, well, that X, is that like a variable? Is that like a letter that we're using? Is that an operation sign? We don't know. So there's a couple of different ways with algebraic expressions that we represent multiplication. So one way is to replace this multiplication sign with a dot between the two. So this still means 5 times 2, which of course is still 10. Again, we did not change the value. We just changed the look, so there's no confusion about what this means. A second way that you could also represent multiplication in these algebraic expressions is to use some parentheses, those grouping symbols, my friends. So 5 parenthesis 2, that means 5 times 2, which is still equal to 10. You could also have your 5 in parentheses. So parentheses next to a parentheses, that means multiplication. Again, my friends, that's just a little note about the fact that an x, well, now that's a letter. We might be using that as a variable, but I don't want to get confused with what operation I'm doing and what my variables are and all that stuff, right? So that's why we kind of use these little shorthand, these little shortcuts to help communicate the difference between the operation and a variable. Let's look at a term. Are you having fun yet? Because I so am having fun. All right, so now let's talk about term, okay? Something important to think about with term. Addition, subtraction. I'll tell you what I mean here in a second. A term is the different pieces of the algebraic expression, the different parts of this algebraic expression that are separated by addition or subtraction. So if you see in this example, we only have 3 terms, right? Because we have this multiplication, that's one term. Now we're adding, right? That's going to be the separation between term 1 and term 2. So now r divided by 2, that's my second term. And then we have a subtraction sign right here, my friends. That brings us to our third term, right? So a term, again, my friends, is just the different pieces, the different parts of these algebraic expressions. But important piece, they have to be separated by addition or subtraction, all right? All right, my friends, so the last one that I want to talk about is this word right here, coefficient. And what a coefficient is in this problem, it's the number 12. So it's the number that is assigned to be multiplied by a variable. So 12 times r, right? 12, we know that. R, that's our unknown, that's our variable. So 12 is our coefficient that I'm going to be multiplying by my unknown. Yes, I know that there's a variable right here, and yes, I know that there's a whole number right here. However, my friends, in r over 2, that represents division, and coefficients only go with multiplication. Okay, so now that we have some basics going on, right? Please make sure that these words are in your beautiful math notebook because you're gonna see them again, my friends. Okay, but now let's start looking at them in the context of what they are in, okay? So the first problem that we're going to look at together is page 148, number 6. All right, so for this first example, it's giving us the written expression, so the written algebraic expression, and it's asking us then to put it in the number format, all right? So we have 5 less than y. So think about it like this. If I have 5 less than 9, that means that I took 9 and then I took 5 away from it, right? Same sort of thing here. I have 5 less than y. That means that I started with y and then I took 5 away. So how would we write that as an algebraic expression? So we would write it like this, y minus 5, right? Because we had y, and now I'm going to have 5 less than where I started, right? And we know that less, that's subtraction, right? In this case, my friends, we have 2 terms in this expression because we have y, that counts as 1. It's separated by that subtraction sign, and then 5, that's our second term. Do we have any coefficients? Nope, because we're not doing any multiplication, but we do have a variable. That variable right now is y because I don't know what it is. I don't know what y is, right? But good job. You just took your first written algebraic expression and you put it in a numerical format. Well done. Let's look at number 7. All right, I know this kind of gets smushed, but you can do it. So again, page 148, number 7. So it says 6 times the quantity 2x plus 3y. Now notice I used a capital X because I wanted you to know that's a variable. That's not multiplication, right? What represents multiplication? Well, this word right here, times. That's multiplication, right? Another word I want to point out to you is this word quantity. Quantity, that's amount, right? So what that tells me in this written format is that I'm going to have to use some grouping symbols, some of those little parentheses, right? because I need to find out the quantity of this business before I can do this last piece, which is right here. Don't forget about orders of operations, my friends. Those are still a real thing. So what would this look like, with numbers? Have something like this. I bet you did, because you're so smart. All right, so this shows the quantity, right? Before I'm able to do any multiplication with the number 6, I needed to find out the quantity of 2x, which is represented right here, plus 3y, which is represented right here. And then once I solve this in my grouping symbol, right, then I can multiply by that 6. Is there a different way that we could write this? There's a couple different ways we could write this. So I could have 6 and then just the start of my parentheses. Remember, when a number is just next to parentheses, that's our algebraic way of saying multiplication, right? We could also put the 6 in a parenthesis as well, and then our quantity in that parenthesis. Again, these all represent the same thing. I have not changed the value in anything. Hey, where is our coefficient? Oh, that's right, 2, 2, 2. 3, 3, 3. Those are all coefficients, my friends, because they are matching with a variable that they are being multiplied by, right? So a coefficient is that whole number, or a fraction, or a decimal. I mean, it can be a number, right? But it's paired, it's being multiplied by that variable, right? And in this case, that x, that's a variable, and that y is a variable. Now, here's a cool thing. In this example, x would not be the same as y. It just wouldn't, right? If it was the same, it would be x as well. So just so you know that when you have the same variable, like x, that means it's the same quantity, right? But then if it's a different variable like y, because it's a different amount. All right, so let's keep this fun algebraic expression train, just keep on chugging along, my friends. All right, so our next ones, we're going to look still at page 148, 8, 9, and 10. And all 3 of those problems are talking about this algebraic expression right here. Number 8 is asking us, how many terms do we have in this expression? Well, let's think. What does a term mean again? Terms are parts of our algebraic expressions that are separated by either an addition sign or a subtraction sign. So we're looking for the pieces that are separated by either addition or subtraction, right? So we have 3 terms in this case, my friend. Here's 1, here's 2, and here's 3. We have 3 terms because there's 3 different parts of our algebraic expression that are separated by either the addition or subtraction sign, right? So we have w divided by 4 plus, that's your hint that it's a new term, 12 and a half minus another term, 7z. Now let's talk about question number 9. So question number 9 asks, which of these terms has a coefficient? Well, let's think, right? A coefficient is not just a number that also has a variable somewhere in there, right? A coefficient is the number that is being multiplied by that variable. So if we're looking at this expression right here, my fine people, this represents division. There's no operation in 12 and a half. And then I have 7z. That represents multiplication. So for number 9, when it's asking you which terms have a coefficient, only one of these terms does, right? Because 7z, that means 7 times z. And don't forget, coefficients are tied to multiplication. So what's the coefficient? The coefficient itself is 7. Because 7 is the number that has a buddy, a little multiplication buddy with z, which is our unknown, right? All right, and then number 10 asks, hey, which term is going to be a constant? Which term is not going to change? And it's 12 and a half right here. How do I know that? Well, let's just process it and think, my friends, right? Let's say if I put 8 up here. Well, 8 divided by 4 is 2. But what is if this was 12? Well, 12 divided by 4 is 3. What if this is 44? Well, 44 divided by 4 is 11. You see what I mean? If I change a variable, the whole value of this little term completely changes. Let's look at 7z. If z is 1, well, 7 times 1 is 7. Okay. But what if z is 3? 7 times 3 is 21. So do you see how the value of this term and the value of this term totally depend on whatever the heck that unknown is, whatever that variable is? The only piece that stays the same is 12 and a half. Why? I'm not multiplying it by anything. There's no variable in this term right here, correct, my friends? That means it's staying constant. It's staying the same. It is not changing its value. So that was just a quick, like super fun run through of algebraic expressions and really just like the building blocks, right? What are the pieces of it? Please, my friends, please, please, please make sure that you have these 4 vocabulary words inside your math notebook that you will keep safe and that you will protect forever and ever and ever, and that you have notes about what these mean, right? Because in our next lesson, 3-5, we're gonna start solving stuff. Right. As always, if you have any other questions, please let me know.